Andromeda Galaxy stands out like a shining jewel. Imagine this. If we could travel at the speed of light, it would take us nearly 2.5 million years to reach it. It is the closest galaxy to our Milky Way and contains about 100 billion stars. These stars are not just bright points in the sky, but places that may hold Earth-like planets. According to scientists, Andromeda could be an ideal place for life. Is someone out there looking toward us from a planet somewhere in this galaxy? How could we possibly make this journey? Current technologies such as spacecraft can reach speeds of about 58,000 kilometers per hour. However, researchers are exploring bold ideas like traveling through space using nuclear engines or even warp technology. Leaving Earth, the overview effect. Every journey away from the solar system must begin with facing our own home, Earth. It is not just a blue planet orbiting the sun, but the place that holds all of humanity's history, memories, joys, pains, and every unanswered question. When viewed from the ground, Earth seems endlessly vast, rolling oceans, sprawling continents, and cities glowing bright at night. But when seen from the outside, everything shrinks into a fragile drop of light in a boundless sea of darkness. When we leave Earth's surface and rise into low orbit, from about 100 to roughly 2,000 kilometers above the ground, the familiar world instantly changes. But what overwhelms humans is not the harsh environment. It is the view of Earth from above. This is where the overview effect, the cosmic awakening, becomes a real psychological phenomenon. Most astronauts describe it as a direct strike to their awareness. Anyone who sees Earth from orbit can never return to the way they once thought. From low orbit, we also grasp the true scale of the universe through one shocking detail. All the planets in the solar system can fit within the distance between Earth and the Moon. This shows that the solar system, a structure we consider enormous, is actually unbelievably small when placed in a larger context. Escaping the solar system. To escape Earth's gravity, a spacecraft must reach a speed of 11.2 kilometers per second. To escape the pull of the very star that has sustained us, we must reach 42 kilometers per second, the sun's escape velocity. This is an immense energy barrier that no primitive civilization could ever surpass. But the moment we surpass the sun's escape velocity, we still remain inside the heliosphere, a gigantic magnetic bubble about 200 astronomical units across, created by the flow of the solar wind. Inside this bubble, the sun still protects us from 99% of the high-energy cosmic radiation produced by supernova in the Milky Way. This structure has a boundary, the heliopause, where the pressure of the solar wind weakens completely and gives way to the interstellar medium. Voyager 1, launched in 1977, finally exited the heliosphere in 2012 after more than 45 years. But the most striking part is not the time. It is the distance it has achieved. Voyager 1 is now about 24 billion kilometers from Earth, which is only 0.0000024% of the journey to Andromeda. Data from 2024 shows that Voyager is traveling through a denser-than-expected plasma region, with electron densities around 0.04 to 0.06 per cubic centimeter, nearly 10 times higher than predictions made for decades. This proves that the space between stars is a constantly shifting network of plasma waves, magnetic fields, and streams of high-energy particles. Future technology. The future technologies we are developing show that the desire to leave the solar system has never faded. Breakthrough Starshot is a proposal to use ground-based lasers to push lightweight probes using photon pressure to 20% the speed of light. Fusion-drive nuclear engines offer fuel efficiencies tens of times higher than chemical engines. Antimatter propulsion is the most energy-optimal technology ever conceived, where each gram of matter and antimatter can release energy equivalent to a nuclear bomb. There is even the concept of Alcubierre's warp bubble, though unconfirmed as feasible, which opens the possibility of bending space-time to travel faster than light, without violating relativity. But leaving the solar system is not only a matter of technology, it is a matter of time. Models show that even at 10% the speed of light, a spacecraft would need about 40 years to reach Proxima Centauri, the closest star. But if the target is Andromeda, then the scale enters an entirely different realm. For Andromeda, 0.1 C would require 25 million years. 0.5 C would require 5 million years. And even at 0.999 C, where time dilation allows the crew to experience only a few thousand years, the external universe would still continue for millions. Crossing interstellar space. Crossing beyond the heliopause, our spacecraft enters a region so vast that every human word becomes small. Interstellar space is not a hallway connecting stars. It is an endless desert where light stretches until it loses its color, where every concept of distance becomes surreal. In this place, the nearest star, Proxima Centauri, 4.25 light-years away, is no longer just a measurement. It becomes a challenge to imagination. 1 light-year equals nearly 9.46 trillion kilometers, making the distance to the nearest star feel like trying to walk across the entire history of Earth, from the age of dinosaurs to the modern era. In the interstellar medium, matter density falls to about 0.1 to 0.5 hydrogen atoms per cubic centimeter. But the universe's paradox is this: scarcity makes this place dangerous. At high velocities, every tiny dust particle transforms into a bullet with immense kinetic energy. At 10% the speed of light, even a microscopic grain of dust can create an impact equivalent to a gunshot, punching through a spacecraft's hull. Interstellar space is also where temperature reaches nature's lowest floor, around 2.7 Kelvin, just a touch above absolute zero. Stars do not twinkle. Light does not scatter. Only darkness stretching without end. But this desert is not entirely quiet. It is filled with high-energy cosmic radiation, protons, electrons, and heavy nuclei accelerated by supernova explosions, moving at nearly the speed of light. These particles can pierce spacecraft armor, destroy cells, mutate DNA, and damage electronics. The Milky Way from afar. From the inside, we see the Milky Way only as a faint glowing band, but from the outside, it is a massive whirl with 2 major spiral arms, Perseus and Scutum Centaurus, and smaller ones like the Orion Arm, where the solar system resides. Gaia's data has measured the motion of over 1 billion stars, allowing us to reconstruct the galaxy's precise structure. The galaxy formed 13.6 billion years ago, less than 200 million years after the Big Bang. One of the oldest surviving galaxies that has devoured dozens of smaller galaxies throughout its history. At tens of thousands of light-years away, the Milky Way no longer fills the view. It occupies only a small portion of the sky, much like how the sun appears once we leave low orbit. Beautiful, but no longer commanding. The galaxy that nurtured every form of life we know becomes just one among hundreds of billions. Studies from Hubble and Gaia show that the Milky Way is moving toward Andromeda at 110 kilometers per second. Seen from afar, the 2 galaxies are no longer separate points of light. They are pulling on each other in a gravitational dance that began billions of years ago. Approaching Andromeda, at a distance of millions of light-years, Andromeda begins as a strip so thin it could easily be mistaken for a dust cloud. This is the galaxy 2.5 million light-years away, rushing toward the Milky Way at 110 kilometers per second. At a close enough distance for details to emerge, we begin to see spiral arms extending hundreds of thousands of light-years. Every second, a new star is born in Andromeda, a natural cycle of cosmic renewal. Looking closely, we see brilliant blue star clusters, much hotter and more massive than the Sun, only tens of millions of years old. At the heart of Andromeda, hidden behind layers of dense starlight, is a supermassive black hole weighing 100 to 200 million suns, a place where physics bends, where time stretches so dramatically that a single minute outside could be years within. Conclusion: the imagined journey to the Andromeda Galaxy has revealed a fundamental truth. We are small beings within a cosmic structure far too vast, where every star system, including our own Milky Way, exists in a state of constant motion and perpetual transformation. The distance of 2.5 million light-years is no longer an absolute physical number, but a measure of the limits of our current technology and the boundless capacity of human thought. In the end, the voyage to Andromeda is not about searching for a new destination, but about redefining our place within everything. Earth may be small, but our desire to explore, to reach for life and truth beyond, is infinite and without any boundary.